What's up everybody, welcome back. So part 4 in the AI series tutorial, and today we're gonna start setting up a little bit of the behavior. So we're gonna make the perception work and add the little progress bar above the AI's head when he sees a player. And as you can see, it will work in multiplayer where the other player cannot see the bars of the first player. And each AI has an independent bar that will update independently of each other. So that's how it's going to work. If you like this series, please consider leaving a like, and if you want to get the project files for yourself, you can become a member or a Patreon, and then you will get access to premium channels in the Discord and also a download for this project and other projects as well. So let's start today's video. So first of all, one little thing I want to look at in the animation blueprint. So in the previous video, we added a little bit of smoothing to the aim offset by setting some variables in the details panel of the actual aim offset. I want to increase the smoothing a little bit more. So I'm going to go to the animation blueprint. And in here, inside of the blueprint thread save update animation, I'm going to add an interpolation node to the character Aim Yaw. So this will be smoother, and we can also set the speed over here so we can increase or decrease the turn rate of the upper body. So we want to go to the setter for the character Aim Yaw, and we're going to disconnect it over here. So first we need to get the current character Aim Yaw, and from here we're going to drag off and we're going to interp to, and you want to get the float interp to, so f interp to. And the target that we want to interpolate to is the result of the normalized axis. For the delta time, we can get it off the event over here, just plug it in. And then we can set the speed at which the aim yaw will change. And in my example project, I've set it to 4. So you can play around with it. If you set it higher, it will turn faster. If you set it lower, it will turn a bit slower. Okay, so we're not really gonna test this right away. We're gonna see how this works later. And as I mentioned, we can increase or decrease this number if you want to play around with the turning speed of the upper body. Okay, so that's a little adjustment in the animation blueprint. And now let's start working on the side detection, as I mentioned. And we're gonna do most of that in the AI controller first. So let's open up our AI controller. And that's actually the first thing that we're going to do in here. So we want to set up the perception system, and then we're going to keep track of an array of all the actors that we perceived, or actually with the sight sense, so that we saw. And we're also going to keep track of how long we saw them, so we can update the progress bar above our head. So we need a bunch of variables to work with, and we also need to get our possessed pawn. So we're going to do that one first. We're going to grab event on possess. And as soon as this fires, this will give us the possessed pawn, and we can simply promote it to variable. So we're not going to cast it to our custom guard class. We're going to keep the amount of hard references as low as possible. So we're simply going to store it as a pawn variable over here. That's good to go. So now we want to take a look at the perception system, and we can actually use an event from the perception component. So if we select it over here and scroll all the way down, here are a few events we can use. So we have on perception updated, forgotten, and then target perception updated, and a few different ones. So those will give either the last perceived information or all the perceived information stored on the perception component, depending on the maximum age that you can set for each stimuli. So the one that we're going to use right now is target perception updated. So let's add this event, and this will fire as soon as the AI perception changes for an actor, and this will give a reference to the actor that has been perceived or stopped being perceived, and also a structure with some information about it. So this is what we need to work with. And the first thing we're going to do if we perceive something is drag off the stimuli, and we're going to get the sense class. So we're going to add multiple senses later. Right now we only have the sight sense, but we're also going to add hearing sense, for example. So we want to know which sense actually perceived something. So we can drag off the return value over here and simply compare it. And then for the class, you want to select the sight sense class. So the normal one, not the config one. Select this one, and then we can simply hook it up to a branch over here. So if this returns true, then we perceived an actor with our sight sense. And we want to keep an array with all of the actors that we perceived. So we're going to create a new variable over here, and let's call this perceived actors. And we're going to change it into an actor. So again, we're not going to cast it to any specific classes. We're just going to use the actor class, and we're going to turn it into an array. And then we also want to know if we perceived the actor successfully or not. So if we entered the sight range or if we left our sight range. So again, we're going to add an array for that, and we're going to call this perceived successfully. And this is going to be an array of booleans. And then we also need the actual times that we perceived an actor. So we're going to add a third array, and those are the perceived times. And that's an array of floats. No, float, this one. So now we have something to work with. So after we perceived something with the sight sense, we're going to drag off the stimuli again, and we can break the structure. So we get a little bit more info about the actual perceived actor. And we want to know if we successfully perceived it or not. So we're going to drag off here, and we're going to hook this up to a branch again. So this goes into the true pin. And then if this one is true, the actor has entered our sight range. And if this is false, the actor has left our sight range. So we can grab our perceived actors array over here. And then if the player entered the sight range or the actor, then we're going to add a unique entry to this array. So you look for add unique. So this will only add it to the array if it's not already in here. And if the actor is already in the array, then this pin will return -1. So we can use that to determine if the actor was already in there or not. So we're going to plug it into the true pin, and the actor comes from the event over here. So we can plug that in directly. There we go. So as I mentioned, this will return -1 if the actor is already in the array. So we're going to hook up a branch in here and check if this is greater than or equal to 0. Plug it in. So if this is true, then it's a new actor that we just perceived that wasn't already in here. So then we're going to also add an entry to our perceived successfully array. So we're going to drag that in and then set an array element. So this goes into the true pin. Then the index is the result from the add unique node over here. So that's the actual index of the actor in the array. So we're going to plug that in. We perceived it successfully. That's what we determined over here. So we can simply set the item to true, and then we want to enable size to fit so we can expand the array if needed. And we also want to add an entry to the perceived times. So we're going to drag that in and also set an array element. The index also comes from the add unique node. So just plug that one in over here as well. Make sure it also has the size to fit enabled, and then the time is simply going to be 0 because this is a new entry in the array. So this is the first time we perceive this actor. Okay, so that's good to go. Now, because we are keeping track of the perceived times, and if the actor left our sight range, we're not going to remove it from the array immediately. We're going to wait until the perceived time is 0. So for that reason, this pin can also fire if the actor is still in the array, but we perceive it again. And in that case, we just want to grab our perceived successfully array. And we only want to set this variable back to true, so we know we perceived this actor successfully. And sorry, for the index, we actually cannot hook this pin up because this will return -1 because the actor was already in the array. So in this case, we want to grab our perceived actors array and we're going to find an entry or an item. And we want to hook up the actor from the event. So we want to find this actor in the array and then make sure we set the correct boolean to true. Okay, so that's the perceived successfully branch. And then we also have the one where we have the player leave our side range. And in that case, we want to do the same thing as we do over here. So we're going to grab these nodes. So we want to get the current entry of that actor in our perceived actors array. So we're going to get the perceived actors and find the actor from the event. And then we're going to say we did not perceive him successfully. So we're going to set the item back to false. And that's all we're going to do in here. So for now, this is the perception updated event. So this will fire every time that the perception for an actor changes. And over here, we're setting up the arrays. Then we need an event that we're going to loop. And in that event, we're going to update the times for the actor that's been perceived. And we can also send an update for the progress bar later from there. And so we're going to create a second, or actually that's our first custom event, but a second event. So let's right click and create a custom event. And I'm going to call this the awareness loop. Awareness loop. And so we don't need to replicate any of this stuff. We are working on an AI controller. An AI controller is server only. So a replication on this blueprint will have no effect at all. So we don't need to worry about that. The first thing we want to do inside of our awareness loop. So we're going to loop this event. We want to loop through our perceived actors, but we're actually going to grab a reversed for each loop. So drag off here and look for reversed. And the reason for that is because we can potentially remove actors from this array. So if we go from top to bottom, if we remove the last index and then proceed, then we won't have any issues. If we go from low to high, that will give issues if we start removing an index from the array. So grab a reversed for each loop, and then the first thing we're going to do in here is check if we have perceived this actor successfully or not. So we can drag in our array and we're going to get a copy of an entry in here, and we want to get it from the array index. So we set it up so all of these arrays are synced up. So each index in the array represents an actor pretty much. And so we want to get the result from here. We're going to hook it up to the loop body with a branch. First of all, if we perceived an actor successfully, we want to get our current perceived times. And again, we want to get it for the correct actor, so we can get it from the array index over here. Like so. And then I'm going to add 0.2 seconds to it. So I'm going to loop this event every 0.2 seconds. So if you want to loop this faster for some reason, then you also want to increase the time that you add over here to the perceived times. So we're going to add 0.2 to it, and then we're going to set the array element again. So this will not update the actual value in the array, so we need to store that. So set array element. This goes in the true pin of the branch. This is the item, and the index again is the index from the for each loop, or the reversed loop in this case. And we don't need to enable size to fit. That should be good to go. We do want to make sure that we clamp this value, by the way. So let's disconnect it, and we're going to look for a clamp float. So this will simply set a minimum and a maximum value for this variable, so it cannot exceed the values that we set in here. So the minimum is going to be 0 and the maximum is going to be 5. So I'm going to set it up after 5 seconds. The actor will actually successfully perceive the player. So after 5 seconds, the bar is completely filled and the AI will start reacting. So if you want to increase or decrease that time, make sure you do it over here, and you can probably, well, let's just drag off here, and we're going to promote this to a variable so it's easier to change as well. So we're going to set it to the maximum perceived time. And then compile it and make sure the default value is 5 or whatever value you prefer. Okay, so that should be good. So this is the perceived successfully branch. And if we have not perceived the actor successfully, we're going to simply subtract 0.2 seconds. So over here, we're going to do pretty much the same thing. We're going to get the perceived items and the set array element node. So copy this and paste it over here. So let's hook this one up to the false pin first. And then from the perceived times, we want to subtract 0.2 in this case. So we're not going to clamp this. We can simply plug it in over here. And we want to make sure that we get the correct index again from the for each loop. So simply hook up the index for the set array element and the get node. And all of the indexes come from the array index over here. So over here we subtract 0.2 seconds, and then after that we want to check if it's 0 or not. So we're going to grab a branch over here, and then we want to get the current perceived time after we set it. So make sure we plug in the index again, and we're going to check if this is less or equal to 0. That's our condition. And if it actually is, then we're going to remove that actor from the array. And we also want to remove the entries from the perceived successfully and the perceived times array. So we're going to do that one first. Let's grab perceived successfully, and we're going to remove an index. Plug it in over here. And then grab the index from the array element again. And then we can copy the remove index node 2 more times. And we want to do the same thing for the other arrays. So grab the perceived times and also the perceived actors. And plug in the indexes. So if the time is 0, then we're actually going to remove the actor from the perceived actors array. Okay, so this should be good to go. Now all we need to do is make sure that we actually loop this event. And we're going to do that with a timer. So let's go back to our target perception updated event. And then on the top branch over here, where we add a new actor to the array and then also add the 2 entries to the perceived successfully array and the times. So this branch, we want to set a timer over here. So we're going to right click and set a timer by function name. Oh. Over here. The function name is simply the name of the function or the event that you want to loop or set in the timer. So in our case, that's the awareness loop. I'm going to copy the name and paste that over here. So I'm going to loop it every 0.2 seconds and then enable looping over here. Now let me quickly double check the settings in my example project. Now this should be good to go. So now we can drag off the return value and promote this to a variable. So we have a reference to it, and I'm going to call this the awareness timer loop. And then when we have that variable, first we can check if it's valid or not. So we're going to drag in a getter and then get an isValid timer handle. And hook this up to a branch over here. So this will make sure that we only create this timer once if we add the first actor to this perceived actor array. If the timer is already running, we're not going to mess with it. We're just going to keep it running. So that's what this part is doing. And then the last thing we want to do now that we have the timer set up is go back to the awareness loop. And then for the completed pin, we're gonna grab a branch. And we can check if our perceived actors array is empty or not. And if it's totally empty, then we're gonna stop looping the event. So we're gonna grab our perceived actors array and we're gonna simply grab an isEmpty node. Plug that in over here, and if this is true, then we're gonna drag in the timer reference, and we can drag over here and do invalidate timer. So clear and invalidate timer by handle. Plug this one into the true pin, and this will make sure that our timer stops looping, and also that the reference over here becomes invalid. So then the next time if an actor gets perceived, it will create a new time. Okay, so this part should be good to go, and that's actually the most of the parts that we're gonna do on the AI controller. So we can quickly test this. If we go to the awareness loop over here, and then at the end we can add a little print. So let's add a print string to make sure that everything is working as we intended. So we want to plug in the actual perceived time for the current actor. So we can grab one of the perceived getters over here, plug in the array element index, and this is going to be the string. And let's make sure 2 seconds, that's fine. So we have it hooked up to the true branch over here, and we can also hook it up to the other branch. So what we can do, just hook it up to the false pin over here, for example. So that's the check for the perceived times is less than or equal to 0 after we subtracted minus 0.2. So if that's false, we can update the print as well, and that should work. So now if we go in game, let's do it one player first. That's a little bit easier to see. And we still have the movement testing set up in the pawn, so let's get rid of that. Let's open our guard. And in begin play, at the beginning, we have some testing stuff set up to test the rotation and the movement. So if we go to begin play, then we can simply disconnect it after we add the weapon mesh to the component. So this is the move to node, and that's rotating. Yeah. So after we add the weapon mesh, then we can disconnect event begin play, and then we should be good to test this. So now if we walk inside of the side perception, there should be a timer that starts looping, and it's actually not working. So let's grab our gameplay debugger to make sure that we are being perceived, and we are. So that's a little issue maybe. Okay. So let me quickly check what's going on, and I'll be back. Okay, that was a little screw up on my end. So if we go into the AI controller, I hooked up the wrong pin for the isValid timer handle. So we want to create a new timer if it's currently not valid. So if this returns false, we want to continue. If it's true, we're not going to do anything. So now this will work. So let's hit play. And we're actually inside of the side range as soon as we start the level. So you can see the value going up. It's not going to go higher than 5, but if we leave the side range, you can see it going down again. And then it'll stop looping if it reaches 0. And if we enter the range again, that's working. And if we go in and out, it should go up and down, as it is. So that seems to be good. And now that we have those times stored, we can start working on the actual widget above the AI's head. To get our progress bar working, we need to do a bunch of setup first. And so as I mentioned briefly earlier, we're going to keep the amount of hard references in this project to a minimum. So it's simply more optimized, and that's generally a good thing to do. So we want to use interfaces, and we also want to make sure that this AI is easy to implement in other projects. So we're also going to use components. So we're going to need to set up some of that stuff first before we can actually continue. So let's start with an interface, and we're going to create one for the player pawn first. So I want to add that one to the blueprints folder. Right click, and we're going to go to blueprint and create a blueprint interface. So let's call this BPI, and then for the AI project, and this is my player pawn interface. So as I mentioned, we're going to be using interfaces quite a lot. So what I tend to do is simply name them after the class they are made for, pretty much. And then I'm only going to implement this interface into the player pawn or the player character. And all of the stuff that the player character needs to do is going to be in that interface. So I'm going to keep things a little bit cleaner that way, and also not end up with one interface that has 100 different functions inside of it, for example. So if you're not familiar with interfaces, you can add an interface to an actor, and then you can simply message that interface to fire an event or a function without casting to a specific class first. So we can use this to prevent getting too many hard references in the project. Okay, so we have the AI player pawn interface. We're going to set this one up first. The name of the function is going to be update AI awareness. Update AI awareness. Oh, there we go. And we do need 2 inputs for this event. So we're going to add a first input, and that's going to be the perceiving AI. And we want to make sure that we set this to an actor reference. So that's something to keep in mind. If you use interfaces to get rid of your hard references, then you don't want to end up actually adding a class in here as an input or an output, because that's just as much an hard reference as casting to it. So as soon as you have a pin in here that refers to your custom character class, for example, that class will be included in the interface, and the entire intention of creating an interface is gone. So we're simply going to use an actor in here, and then we're also going to add a second entry, and that's the perceived time. So that's going to be a float, and that's all we need to do in here. So we have the interface function set up. Then we're going to create a second interface, and that's going to be used for the AI pawn, so the AI character. And I want to add that in a separate folder, to be honest. So I'm going to create a new folder in here and call this behavior. And in here, I'm going to add all the AI stuff. So in here, also the behavior tree, the blackboard, EQS, all that kind of stuff is going to be in this folder. So I'm going to add the AI interface in here. Let's right click, blueprint, create a blueprint interface. This is going to be BPI AI, and then the pawn interface. So simply for the AI pawn. Let's open this up as well and set it up. So in here we want to we want to use this to remove the widget component that we created. So let's call this function remove widget component. And we actually want to give this an input, and that's an actor component. So let's add one input in here. Let's call this widget. And then we're going to set it to an actor component. Like so. Compile and save that one. So those are the interfaces that we're going to use for now. And we also need the actual progress bar as a widget. So let's create that one inside of the blueprints folder. Let's right click, go to user interface, and then a widget blueprint. And we want to create a new user widget. So select that one. And then we're going to call this something like widget blueprint perception progress bar. And let's set it up first. So this is going to be pretty simple. All I want to do in here is grab a progress bar and drag it on top of the widget over here. So we want to make sure that this progress bar is a variable. So let's rename it progress bar perception. And after we renamed it, it automatically became a variable. So we can set up a few different things, like how it looks, for example. I'm not going to go into that too much. So let me see. I've changed the fill color and opacity a little bit. Well, you can set it up like you want. So over here, if you set the percent, you can see both of the colors for the fill and the empty, and you can set them over here for the bar fill style, and then we have the color and opacity. So mess around with it, make it look however you want. The important thing is that it's set from left to right for now. Then we can go to the graph and create a simple event to update it. So we don't need any of this stuff. We do need one variable in here, so let's create that one first, and that's going to be the maximum perceived time. So it's going to be a float, and remember, in our player controller I've set this to 5 seconds, so you want to make sure that this time matches the time in the player controller that you have set for the maximum time. And then we can create a custom event and call this update bar. We need one input for the event, and that's the actual perceived time. So that's a float. And then we can grab our progress bar over here and set the percent. So we need to set a percentage. So we need to do a small calculation first. We can drag off the perceived time and divide it through the maximum perceived time. And that should work. Now let's make sure that we clamp it so it doesn't exceed any maximum values. So let's clamp float. And this percent goes from 0 to 1, so we can simply plug it in directly, and that should be good to go. So this is our entire widget. Let's compile and save that. And then we need another thing to make this work. So we're also going to create a component that we can add to the player character. So we don't have to add any custom code to a character. If we migrate this into another project, we can simply add the component, and that will take care of everything. So let's create it inside of the blueprints folder as well. Right click, and then we're going to go to blueprint class and create an actor component. So let's call this our BP player AI component, for example. Open it up. And let's see, what are we going to do in here? We need to make sure that inside of this component, we're going to create the perception progress bar. So we're going to use the replication part to our advantage, and we're only going to replicate to the owning client to create the progress bar. So that will make sure that if we don't replicate the creation of the progress bar, that only the owning client will actually see it. So that way each player can have his own progress bars on screen. So that's also the reason why we're doing this on the actual player and not on the AI, because it's a bit harder from the AI to get to the owning player that has been perceived by that AI, because the owner of the AI is most likely the server. Okay, so we are gonna do this stuff on the player AI component, and in here we want to create an event that's called update awareness. So let's create a custom event, call this update awareness. And in here we're gonna need the two inputs that we also added inside of the interface. So the perceiving AI, that was an actor. And then the perceived time, and that was a float. Float over here. And we also want to create an array with the perceived actors on this component. So we're going to add a variable in here and call this all perceiving actors. Perceiving actors. So those are all the actors that perceived me, the player. So this is going to be an actor, and then turn it into an array. So when this event fires, we're going to grab all of our perceiving actors, and we're going to add a unique one to it again. So we used this node before. It will only add it to the array if it's not already in here, and we can use the index to determine what happened. So we're going to grab a branch and check if the index is greater than or equal to 0. So if it is, this is a new entry into the array, and because that's a new entry in the array, we need to create a progress bar. So what we are going to do is add a widget component. Yeah, and we want to add that widget component to the AI character. So we're not going to add it to the player character because we need to display it above the AI's head. So we can drag off the perceiving AI and we can add a component by class. So hook this one up to the true pin, and we want to add a widget component. So let's look for widget components. This one, the normal one. And then we want to add a relative transform. So we're gonna auto attach it, but we're gonna give it an offset. So drag off the transform, make a transform. And then for the Z location, I'm gonna raise it 100 units. So it's above the AI's head. So with this widget component added to the AI, we want to make sure that we store this in an array so we can get rid of it later. So let's do that first. We're going to create an AI for all of the components. All widget components. And this is going to be an AI of widget, an array of widget components. So let's set it to widget components. And make sure it's an array. So then we can drag it in here and we can set an array element. Plug it in over here. So the item is the return value and the index is the result of the add unique node. So we can go to the beginning over here and plug it in. So these arrays will sync up again. So index 2 in this array points to an actor, and index 2 in that array points to the widget on that actor. So we need to enable size to fit over here to make sure the array actually expands. And then we need the return value a couple times more. But first we need to make sure that we actually set this widget component to our ProgressBar widget. So we can do that by using the create widget node. Plug it in over here. So we want to create our perception ProgressBar widget. So select that one in here. The owning player we can simply drag off here and get the owning player. And now that I actually hooked that one up, I forgot to go over here. And we need to make sure that we set the replication for this event to run on the owning client. So this will replicate to the actual owning client of the player. And because we are on the owning client, we can simply do get owning. We don't want to get owning player. We're going to get off here and we're going to get a player controller. This one, and simply get index 0, and then we should be good to go over here. So we have this progress bar created, and we also need to keep a reference to this progress bar because we need to call our update bar event on there. So from here, we can drag off and promote it to a variable. So we're going to turn this into an array. So let's call this all widget blueprint progress bars. And then we can delete it over here, turn it into an array, and then we need to drag it in, and we're going to set an array element again. Hook it up over here. So this array element is the actual widget. So that's the item. We need to enable size to fit. And again, the index comes from the add unique node. So all of these indexes still match up. Then we need to set the widget component to actually use this widget. So we can drag off the return value from the add component class. And then over here we can say set widget. So set the widget on the component. Plug this in over here. And the widget that we're going to use is the progress bar. So we want to drag the return value of the create widget node and plug that one into the widget over here. So now we need to set up a few variables on the actual widget component. So drag off here again, and we're gonna set the draw size. So with this node, we can determine the size of the progress bar on the player screen. And I'm using 100 by 10, but you can play around with this if you like and change the size for yourself. And then we want to drag off the widget component again, and we're going to set the widget space. So we want to set it to screen space. So let's connect it over here and change it to screen space. That's good to go. And then the last thing that we want to do is actually update the bar on the actual widget component. So now we need to grab the return value from the create widget node again. Go all the way to the end, and we're going to update the bar. Plug that one in over here, and the perceived time comes from the actual event. So we can go all the way to the beginning and plug that in over here. So if we add a new entry to our perceiving actor array, we're going to create the progress bar. And now if we already have that actor in the array and the progress bar is already there, then all we need to do is update it. So now we can grab the false pin after the add unique node, and we want to grab another branch in here. So now we want to make sure that our value is actually less than 5 and greater than 0. So we're going to drag off the perceived time, and we're going to do greater than. So not equal, but simply greater. And we're going to say 5. And then we want to grab it again, and this time we want to do less. So not equal, but less, and less than 0. So important to notice over here, the first time that we're going to come into this event, this will always be 0.2. So the perceived time is never 0, because we already entered added 0.2 in the player controller to it before we're going to call this event. So for that reason, if it's actually 0 over here, that means we want to delete it. So we don't want to use an equal. And I'm actually screwing this up, by the way, because I'm sorry. We want to say less than 5 and greater than 0. So otherwise it's not going to work, obviously. So if we're in between this range, then we're going to simply update the bar. So let's make sure that we grab an end bool over here and turn this into our condition. So now we want to update the bar, and we need to get the correct bar for that. So how can we do that? We can grab our perceiving actors array and find an entry in here. So we want to find our perceiving AI. And this index is the correct index for the widget component in here, and also for the progress bar. So now we can make sure that this is actually greater than or equal to 0. So it actually found something. We're going to hook this one up to a branch, and that goes into the true pin over here. So if this returns true, then we want to update our progress bar, so we can grab the actual widget and then get an entry from that array. So that's going to be the result of the find node. And then from here we can update the bar. So call update bar and simply plug in the perceived time from the event again. Over here. And then if this is false, then we want to get rid of the progress bar. So we can grab another branch in here. And again, we're going to make sure that we actually find the actor that we're looking for in the array. So we're going to use the find node and hook up the result to a greater than or equal to 0. Plug that in over here. So if this is true, then we found the correct actor. Then we're going to grab the widget component, and we're going to get the matching index from there. So plug this one into the find node again. And what we want to do over here is call our interface that will remove the component. So let's drag off the actor, and we're simply going to say remove widget component. And as you can see over here, this is a message function, and that means it will call the interface. So this is the function that we need. And you can see by the little envelope over here, again, it's an interface function. So plug this one in. Now this is actually not the target because the interface is added to the actor and not to the widget component. So the target is going to be the perceiving AI over here. And then the widget that we want to remove is the widget component from the array. Now the reason that we're using an interface over here and not simply drag off and do destroy component is because this is a component that's on the player character, and we created the component with the target as the perceiving AI actor. So this actor is the owner of the component, and components can only be destroyed by their owners. So if we simply do this over here, nothing will happen and the component will still be there. So that's the reason why we need to use an interface to get to the actual actor and then remove the component from there. Otherwise, it's not going to work. So that's why we're doing that over here. And then after we remove the widget bar component, we need to make sure we update the arrays. And we want to make sure that we remove the perceiving actor last. So first we're going to grab the widget components array, for example. And we're going to remove an index because we only know the correct index and not the correct item. So this is a bit easier, but if we remove it from the perceiving actors array first, our find node doesn't work anymore. So we need to make sure that we do that array last. So we're going to remove a component from the widget components. Then we're going to remove a widget from the widget bars. So again, remove index. And again, this is the result of the find node. And then the last thing is the perceiving actors. And again, remove an index from here. And that's the result of the find node as well. There we go. Okay, so that should be good to go. And let me see. No, that's actually what we're going to do in here. There is one small note that I want to make. So we are looping this event essentially every 0.2 seconds. So this is going to be called in the awareness loop if we want to update the progress bar. So we want to optimize it a little bit. Now we have this event set as a replicated event. And over here, for example, we are dragging off this find node like 8 or 9 times or whatever. And this is a pure node. So every time we drag off here, this will execute the find again. So it needs to find the actor in the array again. So what we would normally prefer to do in this case is drag off here and promote this to a variable, for example. Now we could use a function and then promote it to a local variable so we don't end up with a bunch of variables inside of our blueprint and clutter everything. It's also a little bit better optimized if it's a local variable. And then if we have that variable stored, we only have to do the actual finding in the array once. And after that, we can simply retrieve the variable. So that's a easier and faster operation than finding an actor in an array. But to use a local variable, we need to be able to create a function. So that would mean adding a second call in here because we cannot make a function replicated. So then we need to create call the replicated event. The event will call the function and that will run. So that will add an extra call in there. And because we are executing this pretty fast, that's something I don't want to do. So long story short, I'm going to promote this result of the find node to a normal variable, and then we're going to replace that over here. So this is a little bit of optimization. It's optional, but I'd say you do it. So we're going to drag off the find node, promote to variable, and call this current index. Nope. So we want to hook that up to the false pin over here, and then hook it back up to the branch. And now we can simply, we can make our lives a little bit easier if we disconnect it here first. We're going to grab a getter, hold Control and simply move over all the pins and then plug this one back in over here. So now it's simply using the stored variable and it's only doing this once. And over here we have the add unique node, and this is actually different because this has execution pins. So this is not a pure node, but this is a impure node. So this will fire once, and then this will be a variable that can be retrieved. So if you drag off this return node multiple times, it doesn't actually do the add unique multiple times. So for that reason, we don't really need to do it over here. Okay, so all of that stuff out of the way, and this should be the AI player component for now. So let's compile and save, and let's continue setting up everything in the AI path. We actually have all of the parts that we need in place. So now all we need to do is connect everything up with our interfaces. So first of all, let's go to our AI guard. So the character, open this one up. And in here, we want to add the interface first. So we want to go to the class settings and then go to implemented interfaces. And for this one, we want to implement the AI pawn interface. So not player pawn, but the AI pawn. So after we entered it, it will pop up over here. We can double click the event or function and it will create it for us. So what we want to do, remove the actual widget component. So that's not going to be too hard. First of all, let's simply drag off the widget component and make sure that it's valid. That's always a safe thing to do. And then we're simply going to destroy the component. So let's drag off it again and do destroy component and hook it up to the valid pin. So now if we call the interface function on this actor, it will remove the component. Compile and save. That's the AI character. Now we want to do the player character. So let's close it down. In this case, I want to go to the third person character, but depending on your project, that could be different. So in here, we want to add our component that we created. So we have all of that functionality in place. So we're going to add a component, and that's our player AI component. So it's simply here. We don't need to worry about it too much. And we also want to add the interface. So we want to go to class settings and implement an interface. And this time it's the player pawn interface. Add this one. And then we can set up the event. So let's double click it. And for this one, we simply want to grab our player AI component. And on the AI component, we want to call our update awareness. And then hook it up over here, like so. Compile and save. So that's the character part. And now the last thing we want to do is go back to our AI controller. So go to AI guard, open the controller, and inside of the awareness loop, we're going to call our interface if we have our perceived times reach 0 or if it reaches 5. So inside of the awareness loop, first of all, let's do the upper branch where the perceived successfully is true, and then at the end, let's disconnect the print because we have our progress bar now. We can get the current perceived times again. So let's get rid of this. We want to grab the index from the array element like we used to, and then we can call our interface function on the actual AI. So that's the array element from the perceived actors loop. Oh, sorry, that's not the AI, that's the player, by the way. So we're going to call the update awareness. And we want to make sure that we call the message function, so the interface one. Plug that one in over here. The perceiving AI is a reference to the possessed pawn of this controller. So we have that stored inside of our variables. We can plug in the possessed pawn over here and then plug in the perceived time like so. So this will update or create the progress bar. And we need to do the same thing if the value reaches 0. So then it will remove the progress bar. So we can do that over here at the bottom after we subtracted 0.2 seconds and then before the branch over here. So let's make a little bit of room. And then we can grab this part. So the update awareness interface call, we can paste it in over here. And again, the target is the array element from the for each loop. So plug that one in over there, and then the other node needs to have the index connected. So again, we're going to hook that up to the index of the for each loop. And this should make sure that the bar gets removed if the value reaches 0. Yeah, that should be good. Okay, so now everything should actually be connected up and it should work. So let's have a quick look and let's do single player first. Why not? So as I mentioned, I'm inside of the side range, so the bar is already filling up and it's also depleting if I'm leaving side range. So that seems to be pretty good. It pops back up again, and if I go hiding, so that seems to be working pretty good. Now let's make sure this also works in multiplayer, and I'm quickly gonna move my pawn back a little bit so I'm not inside of the sight range immediately. So let's grab a viewport and let's move our player start backwards a little bit. There we go. Now let's make sure we have 2 players in the game. And make sure that each player has its own unique bars and they don't mess with each other. So this player can create a bar and this player doesn't see it. So that should be good. Now this flickering is simply because we remove the bar if the value is 5 and we're not actually doing anything. So later we will actually have the AI react and this will be fixed. So the other player can create its own bar and it will update independently. So that seems to be working and none of the players see each other's bars. So that should be good as well. There we go. So we have the progress bars set up and done. There are no errors and it actually worked the first time for a change. So that's nice. Yeah, it's been a pretty long episode already, but I want to make sure that I explain what I do instead of just have you guys copy and paste the notes. So hopefully you appreciate it and I hope you liked the episode. If you did, please consider leaving a like and I'll be back soon for more. Later guys and girls, talk to you later.